Hello everyone, welcome to Practical Mechanics. I'm Mohsen. Today's video is about the first lesson in static. And mechanics is a very old science, physical science, and deals with the state of rest or the state of motion under the action of forces. If it is the state of rest, it's the field of static. If it is considered the body under the action of forces, state of motion is the field of dynamic. The first, you can say, scientist or physicist from the mathematician from ancient times that started statics. For example, you can mention Archimedes lived from 287 BC to 212 BC and works on buoyancy. Also, most of the formulas for combination of forces and vectors and hydrostatics done by Simon Stevinus that lived from 5048 to 6020. He was mathematician, engineer, physicist as well, and works in hydrostatics, decimals as well, and mechanics. Today, modern research and development in the field of vibration, stability, strength of structure, and mechanics, rockets, spacecraft design, automatic control, engine performance, fluid flow, electrical machines, apparatus, molecular, atomic, subatomic behavior are highly dependent upon the basic principle of mechanics. Before studying the learning mechanics, especially point of start is static, certain definitions and concepts are basic to this study. The concept should be understood well at the outset. At the beginning, before starting to do anything else, you must understand the concepts. And from this concept that we start today, introduce them and make you ready for the second video, which is lesson number 2 in statics. We start first from the first concept and definition is first one is a space. Space is a three-dimensional region, a geometric region that events takes place. Everything that happens takes place in space. Other is reference plane. For our dynamic and static, we need reference plane. Position in space determined relative to some geometric reference system by means of linear and angular measurement. Force, in definition, force is the action of one body on another, or maybe the actions of several bodies on one object. This force happens with physical contact. And also this action can happen without physical contact, like the force exerted by gravity, electric field, magnetic field. All of them exert forces on some objects. Force tends to move a body in the direction of its action upon the body. The other definition and concept are scalar and vector. Scalar is a quantity which a magnitude alone is associated. Just only has magnitude, volume, surface, length, density, speed, energy, mass. They are scalar. In a static, we work only with mass, volume, surface, and length. Vector. These are quantities, possess. Quantity possess magnitude and direction, both magnitude and direction. And these quantities must obey actually parallelogram law. Vectors must obey. If they don't obey parallelogram law, they are not vectors. Vectors like displacement, change the position from one place to another place. We show it with vector. Velocity, you see we have a speed as a scalar and velocity as a vector, because velocity shows direction as well. Speed just shows only magnitude. Acceleration, force, moment, and momentum. Force and moment, we work with them in static. And how we represent a vector before we go further to other definitions and concepts. We represent a vector by a line segment which shows the magnitude of vector. This shows magnitude. And an arrowhead that shows direction or sense of vector. Arrowhead shows direction or sense of the vector. Then any vector is a line segment. The magnitude of this line segment shows its magnitude of the vector. Represent the magnitude. And sense is shown by arrow. Direction shows by arrow. How we write it? We can write it vector, call it vector A with arrow above it. Some printed like that, some printed perfect, some just printed in the book bold. But we cannot show it in our writing, the bold. There, and maybe confusion happened that this is a magnitude or this is a vector. Then we use one of these two to represent a vector. And if you wanted to show only magnitude, then you can show just letter alone, or under absolute value, the vector, it shows the magnitude of the vector. This is how vector is represented. We have three types of vector. Vectors, one free vector, second sliding vector, third fixed vector. Free vectors are vectors because each vector has a line of action. The line that the vector is a line that, we called it line of actions. For example, for this vector, this blue line is line of action of the vector. If the vector can go up and down, but parallel to the original position, configuration, can go up and down, there is a vector, can go here, can go here, can go here. In this case, if we can change the location, position of the vector, but with one condition, it must be parallel to itself. This is called free vectors. When we use it, for example, when we want to show the displacement of an object in a space, for example, this object can be displaced in a space, we just show displacement, choose a point, and show it with this vector that it displaces it in this direction. Anybody else can show this point, select this point and show the vector here. Somebody else maybe shows this point and show displacement with this. All of them are the same vector in different line of actions and point of action as well. This is point of action, and these are line of actions. This is free vector. Then you know what is in static. We don't use free vectors, especially for couples, only for couples. Only for couples of moments on the surface. It can move anywhere, any point. It has no specific point of action related to that. So when we say that, okay, it is free to move, this couple free to move in its surface anywhere, that's a free vector. Sliding vectors. Static likes this one. Sliding vectors. You can change the point of action, but the line of action is fixed. You cannot change the line of action of the vector. The vector can move along its line of action. For example, because we work with rigid body. What is rigid body? Rigid body means that there is no deformation or change in distance between its part. That's one of the concepts. Rigid, there is no rigid body at all in the world. Anything that you see is deformable. Even the most rigid one, like concrete and stone, they are deformable as well. Depends how much they deform. Then, assume in static, we have to assume that they are rigid. Objects are rigid. When they consider it as a rigid, it means that the distance between their parts, its part, if it is one object, its part doesn't change. It doesn't deform. It doesn't deform. Then distance between these two points always is fixed. These 2 points always is fixed. These 2 points always. That's the meaning of rigid body. If rigid body, a force acting upon a rigid body, for example, this force, you can change the point of action along its line of actions. I can move the point of action from here to here and slide the vector here, or I can move the point of action here, bring the vector here. It moves, aligns its line of action on the part. All point of action must be on its line of actions. All its point of action must lie on the line of actions. That's the definition for sliding vector. When you change the point of action, its effect doesn't change. This is what happened in a static that we use from, these are actually point that we can change the point of action. We use it going back and forth the force for solving some problems. That's called sliding vectors. And the last one, when the vector is fixed, you cannot change the point of action. You cannot change the line of action. Not only, you cannot change the point of action as well. Vector fixed at this point. Why? Because if you change, because the bodies that you consider are not rigid, are deformable. When the body is deformable, then if the exert force is here, it's completely different when it acts here. This point of action A, point of action B, the two forces F, the same direction, the same magnitude, but two different point of action in the same line of action as well. If you move it, the effect, if you move force F from A to B, its effect will be different because the material deformation will be different. This force causes deformation, and the deformation will change if the point of action of the force changes. We work with this concept in mechanics of material or strengths of material. Most of the forces that we consider, all of them actually, because they cause deformation, considered as a fixed vector. Okay, that's the three types of it. But in a static, we work with most sliding vectors because the material, the body is rigid. Another thing that in a static we must understand well, and is the key to solving problem in a static, to understanding the problem. That's the key point. Is isolation of the body from all other object that is in contact. If you don't do this isolation, you cannot solve the problem. The body in question must be completely isolated from all other bodies. Isolated should exist mentally as well as be represented on paper, just in your mind and on paper. You want to consider the static equilibrium of a beam, you must be able to isolate it in your mind and then show it diagram in the paper. When you isolated the body and show it on paper and show the effects of all other bodies on that, what's the effect of all other bodies on our object? We called them before, we defined them, we called them this effect as force. It means that all external force, because this force is acting on the outer surface of the body, is called external forces. When you show all external forces with the isolated body, this is called free body diagram. Very important in static mechanics of material and mechanics in general, to be able to draw free body diagram for the object is the most important steps that must be taken first before solution starts. If there is a wrong free body diagram, solution will be wrong. You must consider all effects of other bodies first. You must find a vision. How I can get vision, that how I can isolate the object from its surrounding just by practice and practice and practice. Sometimes we say that, oh, in solving this question, I forget to consider the weight of the object. Drawing free body diagram, if you forget to consider the weight or mass of the object as well. Then another concept that we wanted to know is the time and matter, but most of them belongs to dynamic, time for dynamic. Matter actually also, and mass and inertia, these are other concepts that we reach to them. Matter is substance that actually occupy space. And body, object that you consider, is the matter that is bounded by external surfaces. Anything that you consider it, just I draw a shape here. I say that this body here, then this body is a mass or matter, is matter. And it's surrounded by external surfaces. I just show external surfaces. I don't know what's going on inside. In a static, we work with forces that all acted on external surface of the body. If you want to know what is going on inside, this is the subject of mechanics of material, strengths of material. If you consider only the external reactions, forces, that's a static. And that, I think, is enough. If we reach to other definitions and concepts, we explain them on its place when we reach to that. But free body diagram of an isolated body with representing the external forces of the body, that's a free body diagram, isolated body plus external forces, is the most important part in static. Most important part. Before we start working on the free body diagram of objects in static, we just start with working on vectors, parallelogram law, addition and subtraction of vectors, definition for force and moment, and then we go for considering problems in static and starting the statics. Also, we introduce the units for you in the second lesson, which unit for the force we use, and how we add forces, how we subtract forces, and moments as well. All of them are subject of statics. Thank you for watching. See you in the second lesson. Bye now.